All right, we will begin section 8.6 notes by looking at a table which is on the bottom of page 359 in your book. And now this table is showing we really need to see that logarithms are exponents and they follow the same exact properties from exponents. So looking at this table, this entire last section here is review for you. You know all of these properties right here. You may or may not need this column for your notes. We learned back in pre-algebra and algebra 1 that when you multiply like bases, you add their exponents. When you divide like bases, you subtract the exponents. And when you raise a power to a power, you multiply the exponents. We're going to take these properties now and we're going to apply them to the logarithms, because remember, logarithms are exponents. So these properties apply to them and they must follow these properties. So take a minute and write these down. For sure you're going to want this middle column in your notes. Note that all of the bases here would have to be equal bases or these properties don't apply. So that's why it says log base b in all of them. What's important here is to see if you're multiplying something, then when you separate them or expand it, multiplying means that you add the exponents. So when you separate it, it becomes the log m plus the log of n. So we need to be able to think of these properties both ways, forward and backward. If you're expanding it and you split up this multiply, you split it up into adding. If we're combining these into a single log and we have these two adding, we combine them by multiplying these two numbers. M is just a number, n is just a number. If you're combining these two logs, you multiply the two numbers. Again, this comes from the property of exponents. So just as if we're multiplying the numbers, we're adding the logs. If you're dividing these numbers, if you're dividing m by n, you are subtracting the logs, and vice versa. If you're subtracting these logs and you are combining them into a single logarithm, you would be dividing these two numbers. So I want you to connect in your mind with logarithms. Adding is multiplying and subtracting is division. Now this one's a little harder to see, so I try to emphasize this exponent, this q right here. When you have an exponent in the logarithm, I think of it as bouncing down in front. This really is a power raised to a power, just like here with m raised to the n power. A power raised to a power, you multiply exponents. So this log base b of m is a power, and we're raising it to another power of q. That's why over here it's q times log base b of m. So when we're doing these in our examples, I'm going to be referring to this, the easy way that I think of is that this just bounces down in front. So if it's an exponent up here, it bounces down in front of the log. If it's here in front of the log and we want to write it as a single log, it comes back up here as an exponent. Now let's look at some examples where we are using these properties. So here in this first one, I have log base 3 of 9 minus log base 3 of 12. Remember, when you're subtracting the logarithms and we are combining these into a single log, we divide. So this becomes log base 3 of 9 divided by 12. And of course we simplify or reduce that fraction like we always have. So it becomes log base 3 of 3/4. And we're done simplifying. In example 2, we have two properties here that we have to take care of. This 4 sitting out in front is multiplying times the log, so this 4 has to come up and become an exponent here on the x. Likewise, this 2 has to come up and become an exponent on the y. So let's just do the exponent property first. So then I have log base b of x to the 4th plus log base b of y squared. So I've taken care of the exponents. And now since we're adding the logs, when you add exponents you're multiplying. So to write this as a single logarithm, I would write log base b, and again, because of this adding sign, we're multiplying the x to the 4th times the y squared. And now it's written as a single logarithm. In the first two examples, we were using the properties to condense the logs down into a single logarithm. Now in this example, we're going to start with the single logarithm and we are going to expand it. So this is log base 4 of x times the 3rd root of y. Doesn't really look like it, but it is x times the 3rd root of y, in case that's not clear. So we have two things to do, two properties to use. We're going to split up this multiplying by adding the two logs, and we need to take this cube root of y and write it as an exponent of y to the 1/3 power, if you recall from our chapter on roots. So let's split up the multiply into add. So we have log base 4 of x plus log base 4 of y to the 1/3 power. So now we just have one step left of taking this exponent of 1/3 and putting it in front of the log. So then the final expanded answer would be log base 4 of x plus 1/3 times the log base 4 of y. In this next example, again, we want to expand this. So we have, this is a great example. It has all three properties built into one problem. We have some exponents to take care of that we'll be pulling out in front. We are multiplying the x cubed times the y, so when we split that up we'll be adding. And then we're dividing by the z squared, so using that property we'll be subtracting. So let's just split up the multiplying first. So we'd have, when there is no log base right here, we know we're in base 10 and we don't have to write it. So splitting up the multiplying on top, we would just have log of x to the 3rd plus log y, log of y. And again, since we're dividing by z squared, that would become a subtract. So we're subtracting the log of z squared. Next step is to do the exponents. The exponents would bounce down in front, so it would become 3 log of x plus, nothing to do here, so it stays log of y minus, and then the 2 comes down in front, 2 log z. All right, one last example. We are to write this as a single log. First thing, bring the 2 up, it becomes an exponent. So I have log base 3 of 9 squared. I can write 81 plus log base 3 of 27. All right, since I'm adding these, I would need to combine these with multiplying. So it becomes log base 3 of 81 times 27, which is a big number. And on the calculator, it turns out to be 2,187. So those are the examples using the properties of logarithms.